gonna apply يعني the derivatives more to other tools like finding our maximum and minimum values of our functions, which is truly one of the important topics طبعا في applications, because sometimes you don't care about the whole domain. All you care about is where can I find my maximum and minimum values. But in this lecture, in the end, we must come out with two main ideas. أول واحدة, we must be able to differentiate between local هو ليه بيمسح كده between the local maximum and minimum values, okay, our local extreme values, and the absolute extreme value. So we need to distinguish between the two types of extreme values, and we need to know how are we how are we able to find these extreme values in both cases. يعني if I'm dealing with a local, or if I'm looking for an absolute extreme. Okay. طبعا you have heard about this from before. حد يقدر يقول لي any information about finding minimum and maximum of a function of one variable f? What did you do to find your extreme values هنا? I need to find my extreme values. What do I mean by extreme values? My maximum and minimum value of the function. Yusuf, yes?
No, I think we get the derivative and set it equal to 0.
You get your derivative for the, if it exists, يعني if the derivative exists, you're gonna get your derivative with respect to x and equate it to 0, صح? And then you solved, صح? You solve this equation in x, and you solve for x. These x points, you suspect that they have an extreme value, right? Then I have these cases, and my problem will be something, if I graph the function, actually I'll have something like this. This is a function in one variable, لو ده x axis بتاعي, and I graph my function. Then when I put the derivative is equal to 0, actually as if I'm saying that yes, there is an extreme value here, مش كده? Because the derivative or the slope here is a 0. There is a minimum because I have a 0, and so on. يبقى بالتالي that's what you did. You put mathematically the derivative equal to 0, and then you go find the values of x corresponding to this, مثلا say these points A, B, مثلا C, and so on. All these points satisfied. Some of them are maximum, some of them are minimum. Sometimes I have something like this. What did we call حاجة زي كده? I have a slope هنا is equal to 0, but it's neither a maximum nor a minimum. What did we call this point?
Point of inflection.
Points of inflection. يبقى I had an inflection point, مش كده, in which برضو يبقى معنى كده when I put the derivative is a 0, I could come up with maximum, minimum, مش كده, or inflection points. We'll do the same معنا هنا. Okay, this is the job that we want to do, but with functions of two variables. Another thing برضو علشان to determine it's a maximum minimum, if you see the graph خلاص that's it. But if you're doing mathematics, you're gonna go get the second derivative مش كده at your point and check the sign if it's positive or if it's negative, right? If it's positive, what does this mean? What does it mean that the second derivative is a positive? يعني لو أنا بصيت على الجراف بتاعي هنا عند this maximum, actually the graph here is concave down, مش كده? It's concave down, and I have a maximum and I have a maximum point. Actually, when I look at my derivative here, I'll find it negative. يبقى معنى كده إن when I'm looking at my second derivative and I found it concave down, negative, then I have a local maximum point, maximum value. If it's concave up like this case مثلا, يبقى بالتالي my second derivative will be positive, it's concave up, and then I'll have my minimum. يبقى I'll have a local. We call this the second derivative test. Okay, يبقى this is the introduction. We'll do the same بقى using a function of the two variables. But these our problems will look like this. I need to find the extreme values of a function in x and y مثلا, and I need to allocate where the function has the extreme values and what are these values نفسهم يعني. So if I graph any function in x to y, I know it is a surface, هنا بقى الفرق. It's not a curves like before. I have this surface that has these bumps and hill and valleys مش كده. عندي حاجات طالعة فوق. So I could if I have the graph I have everything actually. الدنيا سهلة if I can do graphing all the time يعني. لأن على طول I could distinguish that this is a maximum. It's not the maximum, but it is a maximum in its neighborhood for the surrounding points around it, right? That's why I call this local maximum. Also, this one is the other point here on the top. It is a maximum برضو. Why? Because it is a maximum in the for the nearby problems, for the nearby points, sorry, x and y around my points. Huh? That's why I call it local maximum. Similarly, this point I can call it a local minimum because it is less than any other function value for nearby point x. If I want to write this definition as an inequality, I'll write it like this. I'll say that the function values f of x, y, when I compare it with the function value at this specific point, let's call this point AB, مثلا, okay, I'll find that it is always the f of x, y is always less than or equal, this is f of AB. For what values of x? For x, y near the point AB. If I'm near the point AB and this equation inequality is satisfied, then it is a local maximum point. If I'm talking about minimum, the equivalent mathematical formulation هتبقى كده ان ال f of x و y's compared with the f of a always will be by this time any function value at any x or y around the point
bigger than or equal,
greater than or equal for برضه for points x مش always بس for points x y near the point AB. That's why we call them local. إنما when I'm talking about absolute إيه الفرق بقى? What is the absolute maximum in this curve, in this graph? What is the absolute maximum value? When I'm talking about absolute بقى. عرفنا local, I'm looking at nearby points around my maxima. إنما when I'm looking overall over the whole domain, I'm looking absolute maximum over the whole domain of f, okay? Over the whole domain of f. If it is a maximum, if it satisfies in f of x or y is less than f of a or b, then definitely this f of a or b is an absolute maximum. يبقى لازم أقول over هنكتبها هنا بقى over all x و y in the domain بتاع الفانكشن in the domain of the function f. يبقى we must distinguish between local maximum and local minima. Actually, the easier to obtain are the local maxima and minima. ليه بقى? Why is finding the local is easier than finding the absolute maximum? عشان تجيب local, all you have to do is is satisfy these inequalities in a nearby points, مش كده? How can I distinguish in these 2 points مين فيهم الابسوليوت? Okay, if I got the derivative 0 ماشي, the derivative 0, but I cannot say which one of them is bigger than the other, صح? So if وبعدين كان ممكن when I draw the rest of the graph somewhere else, I could find other bumps another place. But it's not that easy to find the absolute maximum, okay? Okay, but that's why we're gonna say how we're gonna find it, and we put some restrictions to finding our absolute maximum minimum. Okay, يبقى أهم حاجة بس في السلايد دي I want you to be aware between the difference between local maximum minimum and absolute maximum and minimum. Okay. Any questions هنا؟ طيب, let's look at the definitions بقى اللي عندنا في السلايدز. I know that f is an absolute maximum if the values of the function less than the values of AB for all xy in the domain of f. Now we understood that. It's an absolute minimum if the f function for any x to y greater than the values of the function at this AB for the whole xy's in the whole domain. ماشي, for all xy's يعني in the whole domain. And then there comes the local بقى maximum. If I'm looking at points x to y and I'm comparing the function values for xy near the point AB. يعني ايه near the point AB? We know انه if I'm looking هنا في xy plane and this is my point A or B and I'm looking at points near. On the nearby points, definitely will come from a circle around my point centered at this point AB. يبقى as if I'm coming from a disk. That's why the definition has this wording. إن البوينتس بتاعتي جاية من some disk السنتر بتاعه AB. ده معناها إن أنا I'm near my point. يبقى any point هنا in this disk XY should satisfy that f of x or y is less than or equal f at of a or b. Okay, got the idea of the definition. Similarly, بالنسبة للlocal minimum. Okay, but this gives me the definition of the difference between the absolute maximum and the absolute minimum. Yeah, but now we want to start, but I need tools to find first. We're gonna look at how to find our local maximum and minimum. Then we're gonna describe the steps how to find the absolute maximum and minimum. These are totally different ways to find each of them, okay? The first one, I'm now عايزين find our local extrema. ماشي? I have this important theorem from our calculus. It tells me that if f has a local maximum or minimum at a point, then the first order partial, and if the first order exists, the another condition. يبقى أنا عندي هنا two conditions for this theorem. I have an information that f has a local extreme point and the derivatives exist. Then the partial derivatives are all partial derivatives of these functions must be equal to 0. Okay, actually it's the same as in one variable, and we can see it here from this figure. If this is my surface, the lower shaded part there, and I'm looking at this maximum value of the function on the surface, and definitely I'll notice that the derivatives or the slopes of the tangent lines, the red lines to the curves of intersection must be equal to 0 because it's a maximum. It's maximum. يعني إيه maximum? يعني it is greater than any other values around it. يبقى بالتالي I'll have the slope is equal to 0. Definitely all slopes must be equal to 0 at this point. يبقى بالتالي if I looked at the curve of intersection along LY and the tangent line, I'll also find that this slope برضو is 0. يبقى بالتالي I have فعلا my partial derivatives at any extreme value is equal to 0. It is verified or justified from this graph. ماشي? I need to understand what's going on هنا. يبقى in order to have a vision order, when I have a maximum or minimum, then definitely I have a 0 partial derivatives. This is equivalent to is a partial f partial x at the point AB is equal to 0 مش كده? And partial f partial y at the point AB is equal to 0. I could alternatively or equivalently say that the gradient of the function at the point AB is a 0 vector. And I know this is the gradient or the vector of my partial derivatives. Okay, يعني these are both equivalent statements. So let's do the example to check this is valid or verify this theorem. I need هنا to use this example that we wrote before to verify theorem 2. يعني ايه verify theorem 2? يعني am I gonna check where is my maximum and minimum using graphing طبعا. This is the tool I have up till now. وبعدين I'm gonna check this point إذا كان الderivatives عندها is equal to 0 or not. Okay, يبقى this is our job now. Let's first of all graph the function to verify the theorem to find our maximum. يبقى when I do graphing, I rewrite my equations زي ما عارفين بقى, simplify. I'll do completing square. I'll end up with 14 minus x minus 1 squared minus y minus minus 2 whole square. I did completing the square, I arrived at this form. خلاص? When I do my traces, we're used to do this بقى. قلنا ان I want to do traces, but هنا I do traces with a plane parallel YZ plane, and I put my x, my y is equal to 2. Okay, يبقى لما احط يبقى parallel actually لل XZ, sorry, parallel XZ plane. يبقى لو أنا if I put y is equal to 2, يبقى I'll end up with z is equal to 14 minus x minus 1 all squared. What does this mean? This is actually a parabola shifted up by 14. Now if I looked بس على ال XZ plane كده, يبقى parabola shifted by 14 هنا, و shifted عند ال x by 1. يبقى I have something like this, صح? Parabola looking down, right? طب if I did my traces بقى in a
دكتور
plane.
مش المفروض نحط لو عايزين في الاكس زد بلين نحط واي بزيرو مش بتو.
ما انا لسه بقول لك هنا في shift في ال variables بتاعتك. If you put 0 you're gonna get trace بس مش سهل. I'm trying to طالما my problem is already organized بالشكل ده shifted فانا I make use of the shifts. ملهاش معنى اروح اجيب التريسز اللي مع الاكس واي plane part of the parabola والvertex اصلا بتاعي somewhere else.
اوكي.
Most our problems actually were the vertex كان عند 0 0 or somewhere here على الاكسيس. انما this time my vertex of the parabola يعني this is a parabola صح؟ and it is looking ايه؟ It's looking down right؟ والvertex بتاعها فين؟ and the x is equal to كام؟ 1 مش كده؟ and you started with y equals to ايه؟ to 2 right? يعني this point actually is at the point 1 and 2. If I did the same trace نفس الكونسبت بقى but this time هنا parallel لل y z and I put my my x here equal to 1 I have a shift I want to make use of this shift يبقى بالتالي أو this information that I know يبقى هتبقى 14 minus y minus 2 squared. يبقى برضه this is a parabola looking برضه down shifted عند 14 عند z and the vertex برضه بتاعك is equal to and the x is equal to 1 and y equals to 2. But when I want to draw this graph, I simplified things by noticing that I had this shift at the point 1 and 2, so, and I have here a shift at the z start at the level 14, and I have my paraboloid. If I have this paraboloid, that it has this vertex which will be 1, 2, and 14. Got it? Why?
ليه بنعمل جراف؟ ليه ما بنعملش partial derivatives على طول؟
I want to verify the theorem. Okay, and still I don't have the tools. I don't have the tools, and I need to verify the theorem. But I want to find using graph. يبقى from graph or using this graph, what did I deduce? What did I observe? What do you observe from this graph? You have a
maximum point.
You have a maximum value. Actually, this value is a local maximum, and also it's an absolute maximum. Yeah. You are sure it's an absolutely, and your function for the whole domain will still go down, so will be less than. But you have actually a maximum value at the point 1, 2, and actually this function, the value of the function here is 14. This is an absolute maximum value of my function. Okay? Now I have some information from the graph. I have my maximum at this point. All I need to do to verify theorem 2, what do I need to verify theorem 2? If I need to go fetch my partial f partial x, partial f partial y, and plug in the point. So that I said it is really an absolute, it's really a maximum, okay? So I have here fx, which will be 2 minus 2x, okay? وهنا fy will be 4 minus 2y. And then I'm gonna plug it, I don't put it equal to 0. I'm gonna plug the point and check if it's equal to 0. ده الفرق هنا. When I want to verify something, I plug the point in this equation. But when I plugged it, what do I find? 2 minus 2, which is a 0. وهنا هتبقى برضه 4 minus 4, which will be a 0. يبقى yes, it is verified. يبقى كده I verified أو theorem 2 is verified.
دكتور
Yes.
هو أنا can I use any trace يعني أي trace ممكن يديني الابسولوت
يعني
أو البوينت؟
يعني هي التريس احنا معرفينه على ان هو between ال coordinate planes. انما انا هنا قلت انا I'll find the trace in a plane parallel للplane بتاعي. يعني as if الفانكشن يعني كده and I'm going to get a vertical plane هنا مثلا عند x and y is equal to 2 صح؟ بدل ما اعمل التريس بتاعي with the x z plane I'm gonna do my trace with the vertical plane at y equals 2. So it
بس
was
إنه يكون أسهل يعني مش
فهو هنا سهل انه على طول باين لي انه عند البلين ده عند الليفل 14 هنا لقيته بارابولا in this parallel plane. انما لو انا هنا خابط في دي actually هتبقى جزء من البارابولويد بتاعي ومش ده مش هيبقى الفيرتكس هيبقى part of the parabola فاهمه؟ انما هنا كده I could visualize it simpler يعني.
Okay, thank you.
Actually this what you should do يعني when you have shifting مش كنت تاخده كده برضه في calculus 1 if you have shift you could simplify your problem as if it's something like يعني كأني هعمل transformation للأكسيس يعني كأني هقول 14 minus capital X فاهمة؟ كده right? And I know that these new axes مثلا shifted by 1 along the X shifted by 2 along the Y right? مش كنتوا بتعملوا حاجات كده؟ Transform your axes اعمل rotation I usually do this to simplify the problem.
دكتور يعني احنا جبنا الماكسيمم من الجراف وبعدين بس عملنا لها فيريفيكيشن من البارشال ديريفيتيفز.
بالظبط كده ده اللي احنا عملناه. خلاص يبقى now we are sure that if I have a maximum and the derivatives exist then the partial derivatives are equal to 0. ده بقى يجيبني على definition of my critical points بقى. يبقى now I know I have these points at which I will have my extreme values or not يعني such that in the partial derivatives are equal to 0. احنا اتفقنا لما اقول all partial derivatives I could equivalently write the gradient of the function صح is equal هو للزيرو أو it does not exist. يبقى بالتالي a critical point is a point for which the derivatives are zeros أو the derivatives does not exist. Okay, got it? طيب are these points بقى maximum minimum ولا not؟ يبقى critical points اختصارا بقى let's write it like this. They could be ايه بقى؟ either ايه؟ local ايه؟ They could either give me a local maximum value صح؟ أو they could give me زي ما شفنا من الجرافس يعني أو they could give me a local minimum value أو neither nor يعني they could it could be neither neither negative nor sorry negative neither maximum nor minimum صح كده؟ اللي احنا سميناهم بقى في الفانكشن في الفاريبل سميناهم saddle point. يبقى I want to be able to distinguish my critical points to these three cases. خلاص يبقى هنرجع نفس القصة بقى هروح فين؟ هروح للsecond derivative test. Okay. طيب let's see an example of the third case. It's neither a minimum nor a maximum. أما أجي أبص على critical points of this function. Actually هنا I'll see that this function has partial derivative partial f partial x is equal to partial f partial x is negative 2x صح? When I look at this partial f partial x okay and equated by 0 actually I'll have values for x برضه هرجع أجيب partial f partial y which is equal to 2y equated by 0. I'm trying to locate my critical points using the partial derivatives now. طيب solving these equations together, I found that x is equal to 0 and y is equal to 0. Actually, this gave me a point, the point 0, 0. But the point 0, 0 here, actually, this is a point which is a critical point. But 0, 0 from solving these two equations is a critical point. يبقى أنت هتقول لي يبقى بالتالي it's an extreme value. Is it an extreme value? Or can you say yes or no and say why? Why is it an extreme value or why it is not an extreme value?
Well, can't it be considered as a minimum?
Can you consider it as a minimum? What is the definition of a minimum? If I said this is a minimum, you expect that f00 should be less than, صح? مش ده definition? Less than or equal f of xy for all x y near the point 0. Is this satisfied?
No.
If you move on do your traces هنا لما تعمل your traces اما تحط y بزيرو z is equal to negative x squared. This is a parabola looking التريس بتاعك هنا عبارة عن parabola looking down صح؟ اللي هو اليالو كيرف ده صح؟ If you look at the other trace هنا ده حط this time x ب0 يبقى you have z is equal to y squared. Actually this is a parabola looking up ماشي and it has this vertex 0 0. Now انت بتقول لي f00 can I'll consider it as a minimum يعني it's less than any حاجة في surrounding. Now move along الايه؟ move along the yellow curve. انت دلوقتي هتمشي في disk around your points. If you moved هنا هل f00 على الأحمر ده is f00 less than any point على ال xy على ال أو xy على الأصفر؟ Actually it's bigger أكبر منهم صح؟ يبقى this is not satisfied. On the other hand, if you went على البلو لاين كده ومشيت around it وبصيت على f00, is it greater than any other one? لا, it's neither bigger nor smaller than any f of x و y. يبقى لو مشيت هنا هتلاقيها أصغر حاجة، لو مشيت على الأصفر هتلاقيها أكبر حاجة، صح؟ يبقى definitely this is not satisfied. يبقى f00 it is neither less than or equal and or neither greater than or equal any xy surrounding. That's why I say that the point 00 is neither maximum nor minimum. But that's why I call it my saddle point. Actually, this example very illustrative. حتى الشيب بتاعي هنا. If you look at it, it looks like a saddle of a horse. مش كده؟ يبقى I'll find هنا part of it concave up. مش كده؟ و part of it concave إيه؟ concave down. صح؟ يبقى if at the same point you have your curves or traces curve concave up, concave down, يبقى you have neither maximum nor minimum, it's a saddle point. Got the idea of saddle points? طيب we don't want to do graph طبعا. We want to distinguish بقى these cases اللي هي الماكسيمم والمينيمم والsaddle points using our theorem اللي هو زي ما قلنا بقى the second derivative test. يبقى let's do our second derivative test. برضو I'm gonna look at my second derivative. But we know if I have a function x to y, how many second derivatives do I have? I could find a fxx, I could find fyy مش كده and fxy, right? يبقى I have three different partial derivatives. يبقى to determine whether my curve is concave up or concave down, I need this expression. Okay? طبعا في proof للexpression ده, but let's take it كده. بس we can illustrate from the figure before يعني إن this فعلا is true أو verified يعني from the previous example يعني. This expression that relates كل ال second partial derivatives, the product of fxyy, fxx مع fyy and then subtracting mean fxy squared, okay? If this expression is positive, this is the first case بقى. First case, if I have positive, then معناها ايه positive؟ معناها I'm gonna look at my fxx, okay? If it's برضو positive, then I have a local ايه؟ Then I have a local minimum, okay? يبقى I need to look برضو على الساين بتاعت ال second derivative لأن هي أو the other one يعني fyy, it doesn't matter. Or I'm gonna look if it's على ال fxx and it's negative, then I have a local maximum, okay? Else يعني else بمعنى ايه if it's negative then I have a saddle then I have a saddle point. These are the three cases that I can determine my problem from using this expression. The last case, note that if I obtain the zero, actually this test fails and I have to go with the graphing, okay? Got the idea? If I want to verify بقى this expression with the previous one, هلاحظ ايه بقى؟ كانت البروبلم عاملة كده اهي x squared ولا كانت عاملة ايه؟ y squared minus x squared مش كده؟ And then I got my derivative fx يبقى negative 2x and my fxx which is negative 2. أجي أبص هنا على fy which is 2y و fyy which is كام؟ 2. fxy actually will be equal to ايه؟ يوم هنا يجيب بالنسبة ل y is a 0. يبقى when I put my expression d, I'll find that fxx is negative 2, fyy 2 minus 0. Actually, I'll notice here when the signs بتاعت fxx and fyy has opposite signs, this will always be negative, صح؟ And this is always negative لأن الترم اللي بعده actually is a squaring يعني هو 0 squared برضه هيبقى negative يعني يبقى I'll always obtain a negative sign for the d. يبقى if my second derivatives fxx fyy have the opposite signs زي ما حصل بقى في السادل problem بتاعتنا fxx واحدة كانت concave up والتانية كانت concave down يبقى I had my saddle my saddle point here. يبقى when they have opposite signs actually I'll never have an extreme value, I will have a saddle point. If it's positive معناها either they are both negative or they are both positive لأنه if they are both negative فالبرودكت بتاعهم هنا هيبقى ايه؟ positive. So I need to look at this to clarify بقى. ما هو الاثنين البرودكت لو same signs هتبقى في كل الحالات ده positive، بس انما لو each on individual negative او كده يبقى ده هيديترمن اذا كانت بقى زي ما عشان كده we look here بقى. بعد ما اجيب positive for دي برجع تاني ابص على fxx لوحدها. لو هي نفسها positive يبقى it's local minimum، لو هي fxx negative يبقى عندي local local maximum. اوكي got the idea يعني. Okay, now let's do the job بقى. خلاص this is now we know our analysis, defined our problem. We are able now to solve such problems. Let us find local maximum and minimum and saddle point of a function. يبقى what's my steps? First step, find my critical points مش كده. The second step is evaluate the expression اللي هو D and apply the second derivative test. Okay, I'm going to compute D at each one of these points and apply the test. The first step, let's prepare, find my partial f partial x, which is 3x squared minus 12y, partial f partial y, which is negative 12x plus 24y. To find the critical points, it occurs when my gradient is a zero. يعني لما ده is a zero and the other one is a zero, and I'm going to solve them simultaneously. So if I have these two equations, 3x squared minus 12y equals 0. This is equation number 1. Let's write it كده عشان أكتب هنا ال simplification بتاعتها. والequation number 2 اللي هي partial f partial y اللي هي negative 12x plus 24y equals 0. ماشي؟ Simplify before solving better. يعني let's get rid of these constants. يبقى I have here x squared minus 4y equals 0, and هنا عندي negative x plus 2y equals 0. Now let us solve equation 1 and 2. It's always do observation. مين أسهل حاجة to start with? It's obvious if I started with 2, from 2 I could deduce that x is a 2y. And then I'm going to substitute this in equation number.
دكتور هو مش في تاني equation y squared؟
Yes, thank you so much. يبقى x is 2y squared صح؟ برافو, thank you. فبالتالي هتسبستيوت in 1 اللي هي دي x squared مش كده؟ which is ايه بقى؟ هتبقى squaring بقى of the x يبقى هتديك 4y to the power 4 صح؟ minus 4y. طبعا ده كان هيبقى fatal mistake يعني كانت كل البروبلم هتتغير. Cancel out your constants. You're gonna end up with y as a common factor. I end up with y cubed minus 1 equals 0. Take care هنا when you solve equations such كده, you know you have a product مش كده of two brackets equals 0. يبقى either we could say كده either y is equal to 0 or the other bracket اللي هو هنا y cubed minus 1 equal to 0. I must take into consideration all possible solutions. Okay. يبقى now as if I have two paths هنا. يبقى if y is equal to 0, I'll go back in equation 2 مش كده and substitute for my x. يبقى my x is equal to 0. يبقى I have this critical point which is the point 0, 0. When I solve simultaneously. The points must satisfy all equations. هنا on the other hand, I have y cubed minus 1 equals 0. معناها y is a 1. يبقى then my x is equal to 2. يبقى I have now another critical point which is the point 2, 1. Okay. If I have these 2 points, all I have to do is in the second step compute my expression اللي هو D, which is let's rewrite it تاني هنا اهو fxx times fyy minus fxy all squared. Okay. Let's prepare بقى. يبقى I'm gonna go بقى up. Let's write it to the side عشان يبقى معانا. يبقى to prepare for the next step I need my second partial derivatives fxx, fyy, and fxy. Okay. يبقى هنا we have a 6x وهنا عندنا كام؟ حاجة غلط برضو. دي سكوير دي صح؟ احنا ماشيين صح؟ اوكي. مش ساعات بيمسح برضو. يبقى هنا عندك fyy will be 48y, fxy will be, let's take it from here. يبقى with respect to y, I'll have a negative 12. يبقى my expression is equal to 6x times 48y minus 12 all squared. Okay, this is my expression. Let's plug in the points 0, 0 مش كده? And the point A 2, 1. What are the values here? I care about the sign. At 0, 0, I have a negative a 144, which is less than 0. But this is definitely a saddle point from my theorem or my test. Here 2, 1 will be positive or a negative. It's obvious in this term and 2, 1 will be bigger than the other, but it's a positive value. But طالما positive, in addition, I must go back and look at at fxx at the point 2, 1. fxx at this point actually is 6 times a times 2, which is 12, which is a positive. But what is my conclusion back here?
Minimum.
I could put the conclusion better in a table format عشان الدنيا حتى to gather all the information in one table مثلا. I'd say كده I have critical points which were the 0, 0 and the 2, 1. I computed my D, I found that هنا negative وهنا positive, صح? Then I'm gonna go look at my fxx and this is my conclusion. هنا it turned out to be a saddle point. Mean by a saddle point, a saddle point is on the surface, so it's a 0, 0 and plug by f is find the value of z at f 0, 0. يبقى ارجع my function هنا f at 0, 0 is equal to a is equal to 0. يبقى this is my صح? 2, 1 لقيت the positive will fxx positive, then it is a local a. What is this? Local minimum a, local minimum value. If I want this value, I'm gonna plug f at a plug 2 over 1 in my function f of 2, 1 and find my value. Okay. هتطلع كام؟
دكتور هو 0 0 سادل ليه معلش؟
مش انت في التست لو لازم ارجع للتست. التست بيقول لي لو انا عندي الدي نيجاتيف يبقى هنا is not a local minimum nor a maximum. واحنا شرحنا دي انها neither minimum or maximum يبقى it's a saddle point.
اوكي.
If it's positive احنا الكيس بتاعتنا طلعت case 1. It's طلعت positive and the fxx is positive, so it's a local minimum. يبقى I'm applying the test as it is. When I applied بقى f21 هنا بقى I want to find the value. f21 is ايه بقى؟ يبقى f21 بكام هنا؟ f of 21 is equal to كام؟ 8 minus 24 مش عارفة plus 8 مش كده ولا ايه؟ يبقى 16 minus 24 8. يبقى the value here is 8. يبقى the minimum function value for this function is the value 8. Okay? And this is my local minimum value. Got the idea? Any questions? By finding my local maximum minima actually in 2 steps, finding my critical point, then applying the second derivative test. We have some problems given in word كده problem. I want to rewrite this word problem in terms of my function. Let's read it together. بيقول لي find the points on the surface closest to the origin. يبقى unknown هنا مين؟ First of all, I must be very precise. Unknown هنا هي points x, y, z on the surface. mean the surface given by x, y, z squared equals 32. طب ايه الكونديشن على البوينتس دي تاني؟ He wants the points to be closest to the origin. Sorry, أنا قلت surface مش right. I want these points to be close to the origin. كلمة close هترجمها إلى إيه؟ اهي السيرفيس، اهي البوينتس اللي انا بدور عليها على السيرفيس، اهو الاوريجن بتاعي. What do I mean by the points closest to the surface؟
local minimum يا دكتور.
لا، الاول عايزين، ما احنا local minimum of what؟ ما انت لازم تبقى very precise. يبقى انت اللي دلوقتي انت هتحول البروبلم من الوورد
هي هتبقى plane مثلا.
لا انا لا، انا دلوقتي اما اقول لك انا عايزه البوينتس that are closest to the origin. افرض دي البوينتس وفي بوينتس مثلا هنا اهو، ايه الفرق بين البوينتس دي ودي؟ what do I care about الفرق بين
distance.
الديستانس بس كده. يبقى لما تقول لي I want the points closest to a point، يبقى بالتالي I'm looking at the distance between this point and the origin، صح؟ يبقى as if I'm gonna translate this problem ان انا I'm looking for the distance from the origin to the point، اللي هو طبعا known which is ايه؟ the square root of x squared plus y. يبقى I'm starting to get to something اهو، صح؟ صح؟ طب what about my z squared؟ z squared أنا البوينت satisfy الكلام ده، يبقى هي عبارة عن 32 over xy. يبقى as if I'm translating the problem in I want to minimize or find the minimum the minimum value of this distance such that z squared is equal to 32 على xy. صح؟ This is the first step اهو. Can I simplify it more؟ يعني ممكن simplify الحتة دي أكتر to try and solve. ما هنا عندي two equations. I want to write them as one. Can I write كده بقى؟ I want the minimum value of the function but أنا هreduce it بقى ل x و y، وبدل ما وهعتبر الفانكشن بتاعتي هي الديستنس squared. يبقى بالتالي ساعتها هقول x squared. ليه كده squared؟ عشان أخلص من square root. I don't want to keep moving with the square root. يبقى x squared plus y squared plus z squared على السيرفيس is 32 على xy. يبقى all I did I took this term and I plug it فين في ال equation of the distance. يبقى now I have a function of x and y and all I need is to minimize this function. Got the idea? يبقى instead of working with the word problem I worked with this. Now I simplified it more to this form.
دكتور أنا مش فاهمة موضوع المينيمم والفانكشن كده. مش فاهمة اللي هو السكند بوكس دوت. يعني أنا فاهمة إن إحنا عايزين نجيب ال shortest distance between O and P، بس مش فاهمة بعد كده بقى.
ما هو انت فاهمه ان الايكويشن دي x squared plus y squared plus z squared. ولما لو جيت قلت لك هنا خدي السكويرنج بتاع الديستنس، فهتتكلمي على الديستنس سكوير. you got rid of the bracket of the square root.
ماشي اوكي.
وبعدين I know that the points اللي على السيرفيس satisfy the equation of the surface اللي هي دي. instead of writing two equations, the distance and the surface, and I plugged the surface فين؟ الريليشن بتاعت surface I put it فين؟ في distance. فبالتالي أصبح معايا بس two unknowns هنا اللي هما الx والy and the z must be satisfied accordingly.
أنا I mean ليه إحنا يعني why did we assume إن إحنا we're finding the minimum point؟ ليه مثلا ما تبقاش ال maximum point أو حاجة؟
عشان هو قال لي إحنا we translated from the beginning the problem. Find the points closest. كلمة closest إيه؟ النيرست بقى اسميها زي ما انت عايزه، النيرست المينيمم ديستانس، صح؟ اقرب حاجه to the origin. if my surface مثلا يعني زي ما احنا عملنا السكتش ده، دي هتبقى اقرب واضح، بس انا عايزه بقى الماث تدور لي على اقرب بوينت على الايه، على السيرفيس from the origin.
طب دكتور احنا هنا substituted الزد علشان نقلل بس عدد ال variables؟
يعني انت دلوقتي عشان تحوليها لبروبلم you can solve now. انت دلوقتي معاكي two equations. I need the minimum distance اللي هو البوكس الاولاني ده، صح؟ and z square equals 32 على xy. فالطبيعي when I simplify my problem, reduce my problem, انا عندي information اهي z squared هي 32 على xy. I'll put it in my distance formula. يبقى بالتالي بقت x squared plus y squared plus 32 على xy. Now I end up with equation عادية بقى خالص. بيقول لي find the minimum value for this function x squared plus y squared plus 32 على xy. Do I need anything else? لا خلاص. How to locate minimum? Go get your critical point. صح؟ صح يا جماعة؟ I'm gonna go get my critical points وبعدين
critical
وبعدين هنا sometimes حتى I don't need to do الايه؟ No need to do a second derivative test as we see from this problem here. Okay? لأن هتبقى obvious هطلع points أنا هطلع values خلاص I'm only gonna compare values I'll just compare just compare values. But if I have more than one point I'm gonna compare values. Let's do the job كده ليه أنا بقول الكلمتين دول I go get my critical points يبقى partial f partial x اللي هي 2x minus 32 على x squared y the derivative with respect to x and partial f partial y 2y minus 32 على xy squared ماشي خلاص كده what am I gonna do equate by 0 solve simultaneously طيب يبقى دي is a 0 وهنا is a 0 يبقى equation number 1 simplify برضه get rid of the constants على قد ما اقدر 16 على x squared y equal don't get rid of the variables the variables I need them عندك y minus 16 على xy squared يبقى I have these two equations I should بقى do some observations ايه اسهل طريقة to do the job يعني I could rewrite برضو ممكن يمكن لو ده يبين شوية I could rewrite it like this to get rid of the هنا x cubed y equals 16 I should have mentioned something على فكرة before I divided by x and y. Can I do this? يعني أنا لما جيت قلت let us substitute z squared equals 32 على x. Can I do this? Can I فعلا divide by x على y? أنا هل x could be 0 or y could be 0? ما البروبلمز الword problems actually ما ينفعش بالظبط ليه ما ينفعش؟ لأن هو he started قال لي إن x y z squared is equal to 32 دي fixed for any point عندي. But if I put x is a 0 or y is a 0 هيديني 0 equals 32 which is not possible. Okay? يبقى أنا I can conclude إن neither x nor y is equal to 0. خلاص؟ ولا حتى z. ماشي؟ يبقى بالتالي I can simply divide by xy. If I don't have any clue إن ده ما ينفعش على فكرة يبقى take this into consideration. يعني لازم أقول له طب in case ده بزيرو ده مش بزيرو يبقى the word problems do have meanings خلاص يعني لازم الأرقام أظبطها make sure أن I got all possible solutions يعني. فactually I arrived at these two equations 1 and 2. The simplest way to do the job إيه بقى هنا؟ If I took equation 1 and I divided by equation 2, I'll end up with x cubed y على xy cubed is equal to 1, okay? Or xy is equal to x squared minus y squared. If I should rewrite the problem in the simplest possible way to find all solutions وما ضيعش حاجة. Now I know this is a product is equal to 0 and I know in neither x nor y are zeros but these are not solutions. يبقى بالتالي إيه؟ اللي equal to 0 x squared minus y squared هي اللي بزيرو صح؟ يبقى then x is equal to plus or minus y. Okay? يبقى now I have something I have an x is equal to plus or minus y. Where do I plug this بقى؟ I have a relation أهي. And I solved the equation 1 and 2 مع بعض. I ended up with an x is equal to y. يبقى بالتالي I'll plug it in one of these equations مثلا. اللي هي كانت أصلها x cubed y. مش عارفة sometimes they do this in the second lecture بس first lecture لا. أنا I'll send you بقى النوتس اللي هي مظبطة. يبقى minus 16 على كانت إيه بقى xy squared equals 0. يبقى هنا xy cubed هي اللي ب 16. يبقى I plug in any one of these x is equal to y. I'll end up with إيه بقى x power إيه 4. في حاجة غلط أنا عملتها. plus or minus يبقى x is equal to plus or minus y يبقى عندك plus or minus x power 4 equals 16. برضو I should do some observations هنا. Plus or minus x دي معناها two equations x power 4 equals negative 16 and x power 4 equals positive 16. Actually this is rejected, it's impossible صح؟ يبقى I ended up with this which will give me x is plus or minus 2. ماشي؟ يبقى you should دايما tend to go with what is possible and what is not possible to do. طب combine بقى all the information. يبقى لو ال x ب plus or minus 2 then ال y is equal to plus or minus x يعني برضه plus or minus 2. يبقى what are my critical points؟ أنا كل ده عشان ما get my points. يبقى they are either 2 or combinations بقى مش كده؟ برضه I must make a check هل these points satisfies both equations ولا لا. Okay? Actually when I go back I'll find that when they have opposite signs this will never do. لأن هنا هيبقى negative وهنا positive which is wrong. يبقى بالتالي when they have opposite signs برضه these are rejected points. يبقى the only critical points فعلا I have is the point that have similar size. بأي طريقة try to discover what are the points possible. أو ممكن أرجع للsurface نفسها و check on it and so on. يبقى my point must satisfy the surface and must satisfy the two partially derivatives. Okay. طيب. Now I have my points. What is the closest بقى points surface؟ هتقولي إيه بقى؟ Don't do بقى زي ما قلت لك don't do second derivative لأن it won't help. All you have is the point f22 and the point f of -22. One of them must be my minimum. When I substitute in the equation اللي هي x squared plus y squared plus 32 على xy وهنا هتبقى برضو plus وبلس وهنا البرودكت هيديني positive so it's the same actually the same values. يبقى both of them give the same value which is كام؟ which is 16. Okay. يبقى واضح ان انا عندي هنا بقى is it a maximum ولا minimum؟ انا now I know that I have an extreme value for the function at 2, 2 and -2. Is it a maximum or a minimum? How can I guarantee it is the closest, not the furthest point? هي المسألة على بعضها. I don't know if it's clear. How do I know it's the furthest?
أشوف points جنبها.
أشوف points جنبها ممكن دي فكرة. أو مجرد I observe إن ال x وال y على الsurface extend infinitely صح؟ أكيد في points على الsurface where x و y بيروحوا الانفينيتي أكيد very far away from my point صح؟ It seems that this is a minimum or shortest distance. يبقى the distance اللي هي كانت square root of my function بقى اللي هي هتبقى 4. يبقى واضح إن this is a minimum a minimum distance. I'll do it just by observation. Okay, I'm gonna observe that the point extend infinitely, and then this is a minimum distance. Simply كده by simple statement. Okay. There are other problems but you could practice عليهم. Let's do بس other idea.
دكتور
Yes.
معلش هو انا من ساعة ما جبنا الكريتيكال بوينتس انا مش عارفة احنا ليه كانسلد التو بوينتس وبعدين مش فاهمة الباقي الصراحة.
يعني عشان كده بقول لك هي problems needs observation يعني needs to be aware what you are solving and what you're doing exactly. ما هياش مسألة steps وبحلها وخلاص. كل problem will have its own steps. When I solved هنا my partial derivatives صح؟ Together the two equations I ended up with خلاص اتفقنا بال4 points دي صح؟ أيا كان بقى ليه ازاي وصلنا لها من هنا لهنا وصلنا لل4 point. جيت قلت لك حتى if I arrived at these points I need you to make sure that they satisfy the equation. هرجع تاني بالراجع يعني verify أو check double check. لو انت حطيتي opposite signs 2 and -2 هيدوكي ايه؟ هيدوكي -16 هنا صح is equal to 16 which is wrong. يبقى بالتالي I'll go only with the points اللي هم have same signs. وده دايما بيحصل هو بس for this specific problem. I could have a problem that have 4 and 8 critical points. ماشي؟ يعني for this problem when I made my check simple check هو لقيتها مش نافعة. خلاص يبقى I'll exclude these are not on my on my list اللي هم
بعد كده التو بوينتس التانيين هنعمل لهم التشيك بتاع الدي.
بالظبط. لا ما انا مش هعمل دي برضو حتى I don't need هنا to do the D لان هنا as if I'm looking actually as if I'm looking at the absolute minimum برضو فال D doesn't have sense or make sense with the local maximum with the absolute maximum or minimum. overall كده انا عايزه اشوف overall minimum distance في الهول domain. يبقى actually هنا I was looking at the absolute okay for such problem. فدي مش هينفعني بحاجه. ايه اللي ينفعني؟ ان انا هعمل function value comparison. هجيب الفانكشن عند النقطه دي والنقطه الثانيه actually I found them the same. طيب طب is it a maximum or a minimum؟ يبقى بالتالي I'll do another observation الريال بقى بتاع البروبلم. Does it make sense ان انا اقول دي maximum value؟ لا طبعا. الاكس على السيرفيس it could extend infinitely. This is a surface واكيد this surface goes infinitely further away from the origin. فاقرب نقطة actually this point. يبقى it's the closest point not the furthest. يعني it's by observation ملهاش حاجة تانية. ماشي؟ نفس الكلام هنا عايز surface area برضو smallest. يبقى هتدور مين الفانكشن اللي انت بتدور عليها. واضح انها your surface your surface area of a rectangular box. يبقى يبتدي بقى تدور على البوكس. يبقى انت بتدور على البوكس. يبقى مين الانونز هنا؟ هل السيرفيس اريا الانون ولا الدايمنشنز بتاعت البوكس؟ فانا I'll say this rectangular box will have these dimensions. يبقى I can write my surface area as a function of these f of x, y, and z. صح؟ I want the smallest total surface area but I want to minimize this function. طب ايه الكونسترين او ايه الفانكشن الثانيه اللي given؟ بيقول لي ده انا البوكس ده has a fixed volume. يبقى معناه دي information. I know the volume of a box is x, y, z equal v. يبقى I have these two equations. I'm gonna solve بقى او substitute واحد في الثاني زي ما عملنا اللي فات and then get my maximum and minimum. وبرده do some observations. okay؟ يعني عشان ال final answer يبقى ليه meaning I should do some observations. It's simple يعني ما هياش that difficult وكلها problems سهلة اللي احنا بناخدها cubes وحاجات سهلة. okay؟ you're gonna be able to distinguish if it's a maximum minimum. okay? point. طيب now بقى فاضل لنا the other part بقى how to find absolute extrema. Actually احنا قلنا دي difficult problem زي ما شفنا كده من الword problem it was difficult ولازم ابقى فاهم المسألة او عندي الباك جراوند. انما if I'm given a function زي دي y is equal to fx وجي قال لي find the absolute extrema. زي ما قلت لك it's difficult اذا انا عايزه اعملها mathematically من غير graphing. فعشان اسهلها انا gonna say I'm gonna look بس in a closed interval. يبقى I'm gonna look بس على this closed interval from A to B at my function and find my absolute extrema. Extreme value theorem reminder كده بتيجي بسرعة. We're gonna use it again هنا برضو. Extreme value theorem states إيه بقى؟ States that if you're looking for an extreme value of the function in a closed bounded interval like this one, and this is say مثلا your function, يبقى your function is your extreme value is either a critical point in the domain. ماشي؟ It's either a critical point in the domain or in the interval أو a boundary point in the أو a boundary point. اوكي فاكرين الثيرم دي؟ يعني ايه اللي انا قلته ده؟ الاكستريم فاليو ثيرم بتقول لي تاني if you have a function defined على closed interval then you must find an extreme maximum او absolute maximum and an absolute minimum in this domain. ليه بقى؟ لان this maximum or minimum will be either these critical points. واضح ان دي اعلى حاجه يبقى my absolute maximum هنا هو ال critical point او it could be these boundary points. واضح ان المينيمم هنا هو ال boundary point. يبقى what were the steps؟ ايه الستبس اللي كنت بتعملها بقى to find your absolute؟ أول حاجة you should find the critical points in the domain ماشي أو in the interval. تاني حاجة you go look at your boundary points ماشي and you find your extreme values. مين الماكسيموم يعني خبط هنا فين عندي صح؟ دي your extreme values. okay and then you're gonna compare. مفيش second derivative test برضه take care بقى. يبقى برضه هنا to find my absolute in a closed domain, all I have to do is check my critical points, my boundary points, and then compare the values. That's it. Remark or note, please don't do the second derivative test. Please, no second derivative test. خلاص it doesn't have any meaning هنا. ما انا حتى لو عملت second derivative I concluded this is a maximum، ما انا ممكن الاقي الباوندري اعلى منها، ف it doesn't have any sense to make second derivative. زي ما هنا it's a minimum بس الباوندري is less than it. يبقى second won't give me any additional information. Now we want to move on to multivariable function of two variables. يبقى بدل الانترفال from A to B I have a domain, I have a subset in my domain. ماشي؟ يبقى I'm going to look at this subset D in my domain in the whole domain بتاعي، هاخد حتة منه بس. okay, and I'm going to check is this closed. كلمة closed معناها الباوندريز معايا. okay, all boundary points are included. ماشي؟ ده معنى كلمة closed. يعني ايه bounded؟ bounded معناها I can the set can be contained in disk, in some disk. يعني لو اعتبرت الأخضر ده some disk اوكي، يبقى بالتالي I can contain it in some finite disk. يبقى بالتالي ساعتها هقول my domain is ايه؟ is bounded. is ايه؟ is bounded. اوكي؟
دكتور معلش، هو مش المفروض الاكستريم او الابسوليوت مينيمم وماكسيمم بيبقوا اللي هما مثلا في الماكسيمم هيبقى اعلى حاجه over the whole domain؟ احنا ليه عملنا boundaries؟ يعني احنا محتاجين
نحله since the problem is an optimization difficult problem, so that's why I confine myself to a subset in the domain.
بس كده it's not يعني كده
يبقى
احنا مش sure ان احنا هنطلعه.
this is my theorem بقى. يبقى my theorem the extreme value theorem اهو هنا برضو قال لي I can find the absolute just on a closed bounded set. If you are working a closed bounded set you could apply this theorem. If not يبقى you're gonna do يا اما graphing or other searching techniques في higher level بقى of mathematics بنسميها optimization techniques. ماشي؟ إنما if I confine myself to a closed bounded set I simplified the problem a little bit. Got the idea؟ وإزاي closed اتفقنا يعني يكون boundaries included. إزاي bounded يعني يكون contained in a disk. يعني this example of a set دي ده اللي هو defined by y squared less than equal 4 is it bounded? Is it bounded? Bounded يعني إيه؟ Can you define a disk contain all these points ولا لا؟ ده الكويشن. Is it bounded? Is it مجرد من النظر على my set of inequalities. Is it bounded? Can you put all these sets of points اللي هو between these two lines؟ لو ده كده الX أهو الY. Can you define a disk, some disk كده that includes all the points? Actually any disk you're gonna take هيحصل إيه؟ هلاقي في points لسه في أعلى منه مش كده؟ في points outside مهما خدت radius infinity will be برضه won't contain. يبقى it is not bounded. This set is not bounded. يبقى I cannot apply ال extreme value theorem. ماشي؟ Is it closed? Yes, it is closed. ليه؟ لأن I have all the boundary points less than or equal. فبالتالي when I want to apply this theorem بس أبص بصة وأعمل شوية observation على ال domain that I'm working on. Is it bounded closed? Then I'm sure from the extreme value theorem that there must be an absolute maximum and an absolute minimum. يعني ما ينفعش تطلع لي من مسألة absolute تقول لي there is no maximum and there is no minimum. Okay, on a bounded set. There must be at least one absolute maximum and one absolute minimum. ماشي؟ طب ايه steps? Same steps as in one variable. Find your critical points برضو in the domain. Find the extreme values on the boundary of F and then compare the values. Got the idea? يعني لو رجعنا لل one variable اهي نفس الsteps. I want to find the critical points inside the domain. ليه كلمة inside the domain دي؟ لأن if I have a critical point outside and I'm just studying this interval and I don't care about the points outside, صح؟ These are not part of my problem. حتى لو موجودين. I only care the points inside the domain. ماشي؟ That's why this is important. طب extreme boundary points هاجي على boundaries I check my extreme values. This is the second step and then I'm gonna compare all these functional values. Last thing, let's do this example. I think we have time or we don't. is we have. طيب if I want to find بقى absolute maximum and minimum value of a function on the set D. الأول I should الأول analyze كده بالراحة كده my problem, understand what I'm looking for. I'm looking for absolute maximum minimum and I'm given a domain or a set D to find my maximum minimum in. صح? It is defined actually, this set is defined by these inequalities. Y is greater than 0, x less than or equal to, y less than or equal to x. Before solving, let's برضه ايه understand الset اللي انا شغال عليه. Is it closed, bounded and so on. هنا actually in such problems you must sketch. It's not an option, okay? Then you'll have to go على الboundaries كلها to check your extreme values. So in these problems you must do a sketch of the set D that you are finding your extreme values in. ماشي؟ فلو ده الx وال y, I have the first inequality y greater than or equal 0. Let's do another color اهو. ادي اللاين ده. This is the line y is equal to 0 and I want the upper part, صح? The second inequality x is less than or equal to. This is the vertical line اهو and the x is equal to 2 and I want the left side اهو less than or equal. وبعدين the next one y is equal to 2x. This is equation of a line y is equal to 2x مش كده؟ That is a has the slope 2. يبقى I need the lower part, يبقى I need this part. The intersection of these three inequalities will give me the domain of study اللي هو الدي بتاعه. Got it? يبقى أنا I still didn't solve. I'm just understanding my problem. I found that I have a triangle and I want to solve this problem. في حاجة؟ طيب يبقى let's برضو do more بقى, understand more. What about my domain D? Is it closed? Is this D closed? بس كده مجرد observation سريع. Is closed? Yes. ليه closed؟ لأن كل ال boundaries معايا, في qualities كلها معايا, صح؟ Is it bounded? Actually طبعا bounded. أنا رسمتها هي على الورقة. It's finite. It's a simple small triangle. يبقى my domain, my set ده is closed and bounded. And it consists of actually three different equations. It consists of this equation, if let's write it in another color, this one, and consists of another one, layer 2, this one. Can I describe these equations? Actually, when I look at equation number 1, I'll find that I have what is the boundary defined by this part. I called it 1, boundary 1. What is the equation defining this? هو التايم اوف ذا ليكتشر خلاص ولا ايه؟
ده الاكس اكسس او y equals 0 صح؟
y equals 0 بالظبط. If I said y equals 0 does this define the whole y axis? I only need this part, صح؟ To be very specific, it's y equals 0 and my x is bounded from the points 0 to 2, صح يا جماعة؟ You want to describe everything in details عشان to be able to solve. طيب the second boundary this vertical line actually is the line x equals this time 2 مش كده? And my y is bounded between the values كام and كام. You're gonna start from this point which is the point 2 is 0 مش كده? And the intersection point هنا is the point the x is a 2 then the y is a 4. It's a simple يعني ما فيهاش حاجة. هتحط x ب 2 يديك ال y ب 4 صح؟ يبقى it ranges from 0 to 4. This is the range of your y صح؟ You still have another third line which is defined by the equation y is equal to 2x. أنا جبت الكلام ده كله منين؟ From the problem y is equal to 2x and this line is defined for the values of x from 0 to 2. Simply. But now you analyzed your problem, you understood that you're gonna work, but then the extreme value theorem applies. Then I'm gonna apply the extreme value theorem. صح? Let's do the job بقى. Step 1 قال لي اعمل ايه بقى؟ Find my critical points. صح؟ يبقى to find the critical points, I'll go to the function, get my derivative. Let's write the function قصادنا بقى هنا عشان نبقى شايفينها. الفانكشن اهي 2x squared plus y squared minus 2y minus 2x. Okay, now do the job بقى. يبقى fx is 4x minus 2y صح minus 2 partial f partial y which is 2y minus 2x. I'm going to equate by 0. I have simplify at the same time. يبقى عندي 2x minus y equals 1 and the other one is y is equal to x. Okay, then I plug this in 1. I'm going to get the x is equal to 1. صح؟ يبقى y is equal to 1. يبقى I have a critical point which is the point 1, 1 and the function value at this point is equal to, plug by the values, هتطلع كام بقى 2 3 minus كام 4 يبقى negative 4. Okay, يبقى I have all the information about my critical point. Sorry, I forgot to mention when I got my critical point I must make sure it lies in the domain in the set D. Is it in the set D? لما اجي ابص على my problem هلاقي فعلا ايه the point 11 is inside D. This is the point 11 inside D. Okay, يبقى yes I'm okay with it and I will need this point. If it's outside I don't care about it and I don't do anything with it. خلاص. طب the second step I want to get my boundary points. Let's do it جنب الفيجر اهي عشان الدنيا تبقى clear اهي. يبقى the second step we're going to do our boundary extreme values at the boundary points. The first boundary y is equal to 0. يبقى at y is equal to 0 and x from 0 to 2 I'm going to have the function على الباوندري is equal to f of x و 0. ايه اللي انا كاتباه ده بقى؟ The function that I'm dealing with on this boundary has specifically the y0 is equal to 0. خلاص يبقى بالتالي I'm going to simplify the job by putting the information in my function. فبالتالي هنا بقى معايا ايه 2x squared ويبقى plus 0 مش كده minus 0 minus 2x. يبقى بالتالي instead of working with the whole function I'm going to work with the function على الباوندري which is simplified to 2x squared minus 2x. What is the extreme value هنا؟ يبقى I'm going to get my derivative. يبقى معايا 4x minus 2 equals 0 يعني x is equal to half. يبقى now I have a point, a boundary point which is equal to half and the y is a 0. I started with this. Okay, and the function value at this point is هي اللي I care about صح؟ هنا هتبقى كام عند half و 0 هتطلع negative ايه؟ negative half. Got the idea? What did I do? I checked the boundary line اللي هو I called it a boundary line number 1. Now I'll do the same with boundary 2 and so on. Okay? وهكذا بقى. يبقى بالتالي هتيجي عند 2 هتيجي تقول لي ده الاكس هنا ب 2 والواي هي changes from 0 to 4 and then I'm gonna get f at 2 و y هكذا. Okay, and then I go do my derivative and do the job. Got the idea? Any questions? Do you need us to complete it ولا خلاص الidea وضحت؟ Are you still here ولا الناس مشيت؟
ايوه يا دكتور الأيديا وضحت شكرا.
You don't need to continue it. مش كده؟
لا شكرا.
يبقى you're gonna do this بعدين gonna do the last one and y equals 2x وبعدين يبقى بالتالي I'm gonna collect everything بقى. I'll have my critical points and my boundary points اللي هم 1 1 و half و 0 and so on, all the points that I got from the 3 boundaries. Okay, and then I'm gonna compare the function values at these points. The maximum actually will be my absolute minimum and the minimum value will be my absolute. I should end up with definitely واحد أكيد أكبر من كلهم واحد أصغر من كلهم. Got the idea? Okay, let's do our worksheet. I'll put you in breakout rooms. Actually, the problem and the worksheet has a nice idea, one of them. Let's do it together. I'll do only 2 breakout rooms, okay?